Good afternoon, all of you. Welcome to Electrical Engineering 1 tutorial session. Today in this session, we will be starting sheet 2. This sheet 2 has total 10 questions. As I have uploaded, I think you might be seeing on your screen the sheet 2. Okay, it is about in the sheet 1, we have seen the summary about current, voltages, and power in an electric circuit. In sheet 2, we'll see how to determine the value of their variables like current, voltage, and power with the help of some fundamental laws. Okay, we have two fundamental laws. One is called Ohm's law, and another is Kirchhoff laws. Okay, so these two laws we'll see in this sheet. Okay, do all of you able to hear my voice? Am I audible? Shall I continue now? Good, great. Okay, so see today in this session, I think you can download this sheet. Okay, I have already uploaded in the Blackboard also. In this sheet, first we will see the 4 or 5 problems. We will see problem 1 and problem 2 also from sheet 2, problem 1 and problem 2, problem 3 also we'll see, and problem 4 also we'll see. Then after problem 4, after problem 5, we have problem 6, 7 we will skip because we'll solve this next week. And there is one more called problem 7. Okay, we'll solve this. So today in this session we'll solve problem 1, okay, 2, 3, 4, and 7. Okay, so we are going to solve these problems, and next week we'll solve the remaining problems. Is it clear, all of you? So all of you make sure that you have sheet with you. Okay, I'm going to share the screen with whiteboard with me so that you'll be seeing the solves of what I'm solving. So now all of you able to see the whiteboard formula for sheet 2. Okay. Do you see formula for sheet 2? Okay, great. So thank for your response. Yeah, in sheet 2, as I have told you, we'll be seeing how to determine the value of current, voltage, and power with the help of some fundamental laws. Okay, and we have here 2 fundamental laws, Ohm's law and Kirchhoff laws. Okay, but only this Ohm's law and Kirchhoff laws are not sufficient to solve the problem. We need some more techniques, some common techniques to be applied in the circuit to solve the problem. Okay, so what are those things? So let us see that. Ohm's law and Kirchhoff laws, depending on these problems, we'll solve next week. So we will see some other techniques. So let me write. There are some fundamental laws which you are going to see. Fundamental laws. What are those fundamental laws? One is Ohm's law. And another is Kirchhoff laws. Kirchhoff. Okay, Kirchhoff laws. And also with this we will see some techniques also. Okay, what are those techniques? There are many techniques that we have, combining resistors in parallel, combining resistors in series, voltage division, current division, delta to Y to delta transformations. There are many, but we will in this sheet we'll be seeing only few techniques like combining resistors in parallel, resistors in parallel, then resistors in series, and we'll see to a couple of laws, that voltage division law and current division law. Okay, we'll see this. So let us begin with Ohm's law first. Ohm's law states that the voltage V across a resistor is directly proportional to the current flowing through it. Okay, V is directly proportional to I. So if we remove the proportionality constants, then we get V is equal to IR, where R is proportionality constant, which we call it as a resistance. Okay, so R changes if the internal or external conditions of the elements are altered. So what is resistance? It is the ability to resist the flow of electric current. Okay, it is measured in ohms. All of us, we know that. Okay, now the thing you need to understand is this R, this resistance can be, if the resistance value, there are two values for R. What happens if the value of R is 0, and what if a value of R is infinity? Okay, if the value of R, the resistance is 0, then we call it as a short circuit. Okay, and this is what we call it as a perfect conductor. Okay, and if the value of R is infinity, then it is called open circuit. And we know that resistance can be fixed or it can be variable. Okay, so now actually why I have discussed this, because I want to, here we are focusing only on resistance. Okay, the other components we are not taking. Okay, using this resistance, what happens if the resistors are connected in series? Okay, and what happens if the resistors are connected in parallel? What is current division law and what is voltage division law, that we will see. Okay, so I just come down. Yeah, so let us make it little bigger. Okay, so now I write here, if the resistors are connected in series, so all of you know that you might have seen that if the resistors are connected in series, let me just draw one diagram, that suppose you have a voltage source of Vs, and you have resistance 1, resistance 2, resistance 3, all these are connected in series. Maybe all this, suppose all are resistance. Okay, and the current is Is, and this is R1, R2, R3, R4, R6, like this. Okay, then you know that the current which is flowing across all the resistors, if the resistors are in series, is same. Okay, current flowing all the resistors R1, R2, R3, this R4, R5, R6 is same. Okay, so how do you find out the Vs? According to the Ohm's law, just now we see V is equal to IR. Okay, Vs is equal to Is. But R we don't know. So you have to find out R equivalent. Okay, this is the formula here if they are connected in series. So the question is, what is R equivalent? Okay, the question is, what is R equivalent? So R equivalent is nothing but R equivalent. If the resistors are in series, then their equivalent resistance is sum of them, R1 plus R2 plus R3, R4, how many you are having, okay, up to Rn. So please remember this, because all resistors carries the same current. Okay, so do all of you understood this? Any question up to here? Any question? Good. So now what we'll do is, let us put the resistors in parallel. For example, let us take an example of parallel. If I take an example of parallel, I'll just draw a line so that we divide the board. Okay, if the resistors are in parallel, so if the resistors are in parallel, I will just draw an example of same circuit. You have a Vs, R1, R2, R3, so on. There are many. Okay, so and the current that is flowing is I. Suppose I is here also. We have resistance R1, R2, R3, R4, R5. Okay, so here also we apply Ohm's law. According to the Ohm's law, V is equal to IR. Is into R. R what? R equivalent. But here the value of R equivalent will be different. Here R equivalent, because all the resistors are connected in parallel. Okay, so how do you write R equivalent? You will not get R equivalent. You'll get R equivalent by this formula. It is already proved in the theory. 1 by R equivalent is equal to 1 by R1 plus 1 by R2, whatever it is. Okay, so this is the formula. Okay, hope all of you understood up to here. Is it clear, all of you? Do you have any question up to here? Any doubt? Clear, good. So now let us see now. So we have conclusion. Okay, what is conclusion? So I'll just write here conclusions. Resistors in series. I'm just writing for two resistors, okay, R1 and R2. So R equivalent is equal to R1 plus R2. Okay, if the resistors in parallel, okay, I'm writing for two resistors. RQ is equal to 1 by R1 plus 1 by R2. So in short, I can write it as R1 into R2 by R1 plus R2. This is 1 by. How you got this? Just do cross multiplication. This is 1 minute. I'm writing for just two resistance, 1 by R equivalent. So for R equivalent is equal to R1 R2 by R1 plus R2. Okay. Please remember, all these are Khanun. I'm showing you the formulas. Okay. Now, after this, let me show two more formulas. Then we'll start solving the problem. Okay. Now, let us see what do you mean by voltage divider circuit. Okay. Voltage divider law. It states that suppose you have a circuit. Okay. This plus and this minus, and this is the source current, source voltage, and you have two resistance. Okay, and the current which is flowing in this is is. This is the total current. No, this is R1 resistance, this is R2 resistance. Okay, and here this plus minus this V1 voltage across this resistance, plus minus this voltage. See, if the resistance are in series, then voltage get divides. Okay, so voltage get divides. Now what I want is I want to find out V1 and V2. Okay, so what? How do you find out how much is V1? How much is V2? The Vs is getting divided into V1 and V2 according to the voltage divider law, which states that total V1 is equal to what is the total voltage Vs. Okay, the total voltage is Vs multiplied by you see I want V1, so we take in numerator the same resistance by sum of the remaining resistance. Okay, this is an example of, this is the formula for voltage divider law. What is current division law? Let us see current division law. In current division law, okay, let me write the current divider circuit. Suppose I have a circuit in this resistance are connected in parallel, and I have a voltage source. This is R1 and this is R2. Okay, and this is suppose current Is. Okay, so here you are having current what? Is. Now here Is, you know that in parallel current gets divided, but the voltage across them is same. The voltage across parallel resistance are same. Okay, V is same. So what is changing? Current is changing. So this Is is getting divided here. Is is getting divided into I1 here and I2 here. Now according to the current division law, I want to find out I1. According to this current division law, which states that I1 is total current, okay, the opposite resistance is what? R2, the sum of these two resistance, R1 plus R2. Okay, so I mean, just let me repeat here. Similarly, here also you can find out V2 is total voltage V2 and take the R2 by R1 plus R2. So we can find out V1 and V2 with the voltage divider circuit. Similarly, we can find out from here I1 and I2 also. Then I2 is nothing but total current R1 by R1 plus R2. So now tell me, all of you, do you understood all these qanuns? This is very important. All these formulas are very important. We have seen total how many formulas? Okay, first formula V is equal to IR. Okay, second formula to find R equivalent. In series it is R1 plus R2, and in parallel it is R1 R2 by R1 plus R2. Three formulas. Okay, then fourth formula we see that current division law, voltage division law, that is V1 is equal to Vs into R1 plus R2, and V2 is Vs into R2 by R1 plus R2. Then fifth formula we have seen that current division law, which is I1 is equal to Is into R2 by R1 plus R2, and I2 is equal to Is into R1 by R1 plus R2. Okay, so these are the formulas which we are going to solve, which we are going to use in our sheet 2. Okay, so hope all of you it's clear up to here. Okay, shall we proceed to solve the problems now? Okay, okay, that's great. I appreciate for your response. So let's go for problem number 1. So let's go for first problem from sheet 2. Find the equivalent resistance of the network shown in the figure 1. So do all of you see the image clearly? Is it small or it's okay? I hope all of you see it clearly. Okay. So we need to find out here R equivalent. We need to find out R equivalent. It's just asking us to find out R equivalent. Now, how do you find out R equivalent? You see, we find out R equivalent with the help of this circuit. And in this circuit, the components are, randomly, some are connected in series, some are in parallel. Okay. So what I will do is, I will take this circuit. Okay, so I write here step 1. Okay, you see in step 1, you see here uh, these are in series. Okay, both of them are in series. In series, what happens? R equivalent will be, see, 3 and 1 are in series. So R equivalent will be how much? 4. 3 plus 1 is equal to 4 ohms. So what I will do is, I will just erase this. Yeah. And similarly, you see this also, both of them are in series. Correct? This 3 and 4 are in series. So if both are in series, we'll add them. So this also gone. So I will replace them with 4. Okay, this is 4 ohms, and this is also 4 ohms. Okay, all of you, is it clear how you got 4 ohms? Yeah. Now what you have to do is, again I will take this figure. Step 2. No, just see in step 2. You might have seen that, yeah, this is 4 and 12, they are parallel. Okay, and similarly you might have seen this 4 and 4 are also in parallel. Okay, so we write 4 is in parallel with 12. If they are in parallel with 12, what is equivalent? 4 into 12 by 4 plus 12. So 4 into 12 divided by 16. So 4 ones are 4 fours are 16, 4 ones are 4 threes are 12. So you get 3 ohms. So this equivalent I get how much? 3 ohms. And what is this 4 and 4? They are parallel. Okay. If 4 is parallel with 4, so this is 4 into 4 by 4 plus 4, 16 by 8 is 2 ohms. Okay. So here I erase and write that we get 2 ohms here. Okay. One is 3 ohms and another is 2 ohms. So I, oh, sorry. Yeah, same thing here. So I erase this one. Instead of erasing, I will just select this. You see, I cut this also. Okay, I got here 3. I got 3 because you see I got this as 3 ohms. Okay, so I make it as 3 ohm. Similarly, these two parallel, I got 4 and 4 is parallel. I got the equivalent resistance as 2 ohm. So I just cut this and let's write down this is how much. This is 2 ohms. Okay. Yeah. Now you see 3 and 2, again they are in series. Okay, so I just take them, Control C, Control V. Yeah, this is step 3. In step 3, you see these are in series. Okay, so 3 plus 2 is how much? You get 5. So I just I get how much? 5. This is 5 ohms. Okay, and step 4, yeah, step 4, just I will copy this first. Here I will write again step 4. Now see here, these are parallel. They are parallel, correct? So if they are parallel, so how we will solve in step 4? 5 into 5 by 5 plus 5 is 25 by 10, which is 2.5 ohms. Okay, so it means I have to cut this, and I get this circuit, which is 2.5 ohms. Now you see in last step 5, we observed that all of them are in series, correct? So therefore R equivalent is 5 plus 2.5 plus, how much is it? 5. Okay, so therefore R equivalent is 12.5 ohms. I will just divide this lines so that you will not get confused. Yeah, so this is our first solution. So all of you understood this? Any questions? Any question up to here? Okay, good. So it's great. Let's go for next problem. So let's go to solve problem number 2. Okay, this problem 2. Find I naught in the circuit using Ohm's law and current division law. We know that Ohm's law is V is equal to IR, and current division law we also know that what is current division law. Okay, so do all of you able to question number 2 onto your screen? Okay, is it clear? So let me solve this. Okay, so let us solve problem number. So this is it is better we divide our board into two parts, three parts, so that it will be easy for us to solve. Okay, so let us start solve it. Second solution, we need to find out I naught. We need to find out, okay, I naught, and this is the circuit he has given. Now you see, let us do step one. How do you find out I naught? I naught, according to the Ohm's law, you know that Ohm's law, V is equal to IR. So from that, if I is given, if I we need to find out, I is equal to V by R. Okay. So if you solve it again, I is what we need to find out, I naught. Okay. I is here, I naught, and we need to find out V is given here. Okay. V is 36 volts. And we need to find out R is not given because there are many components. I have to find out R equivalent. Okay, so we will get I naught. So for that, the step number one is, let us reduce the circuit. You might have seen that this 10 and 12, they are in series, and 1 and 2 is also in series. So in step one, we get a circuit like this. 10 plus 2 is 12. This is 12 and this is 3 ohms. So I will just replace the circuit with this. So I get this as 12 ohms. This is 6 ohm. This is 12 ohm. And you have got 2 ohms. This is 4 ohms. And this is 36 volts. And here it is given that I naught. And this value, we just replaced it with 3 ohms. Okay, all of you, this is our step number one. Now again, you observe here, you see this 12 and 6, they are parallel, correct? They are parallel, and he has given that this is I naught. So let us, or shall we solve from here only? We have the space, so we'll solve from here only. Let's go for step number, just we'll go down. Still I can take more. Yeah. So let us see step number 2 now. Okay, in step number 2, we will solve 2 is 12 is parallel with 6. So equivalent is 12 into 6 by 12 plus 6. 12 into 6 by 12 plus 6 is 18. 6 ones are 6 threes are 18. 3 ones are 3 fours are 12. So you get 4 ohms. Okay. So this you will get how much? 4. So just we write, I just draw the circuit. 36 volts, and this is 3 ohms, this is 4 ohms, and then I have got 2 ohms, and this is all I replaced it with how much? 4 ohms. So this is 4 ohms. But again, you might have observed that this 2 and 4 are in series. So I can replace it with 6 ohm. Okay. So in step number 3, I can make it 6 ohm. Just I go up here. Yeah, step 3. So this is 6 ohm, and I get 4 ohm and 6 volts. This is 3 ohms. See, this is what I have written: 6 ohm, 3 ohm, 4 ohm, 36 ohm. Okay, and here you have current I naught. Okay, and you have this connect I naught. Now again, you see this 6 and they are parallel. Okay, so 6 is parallel with 3. Equivalent is 6 into 3 by 6 plus 3 is 9. Okay, 18 by 9 is 2 ohms. So I can replace it with 2 ohms. Okay, so I just draw the circuit. Step 4. This is 36 volts. Then you can draw like this or like that. No, don't worry. But only if you draw here, current direction will come here, because you see the direction is going into this point. Okay, so I naught. So this is 2 ohms and this is 4 ohms. And again, it is clear from the figure that both of them are in series. This will become 6 ohm. So step 5. You have 36 volts. Current is coming in this direction, and this entire thing has become 6 ohm. So actually, what is this 6 ohm? Okay, this is R equivalent actually. So we got R equivalent as 6 ohm actually. Okay, so now it's very easy. How do you find out I naught? I is equal to V by R. Okay, V by R equivalent. As I've told you in the beginning. Do you remember this? So V is equal to, V is 36 by R equivalent is how much? 6 ones are 6 are 36, 6 amperes. So therefore, we get I naught is equal to 6 ampere. Okay, this is the solution. So any doubt, any question up to here, all of you? Do you understood this problem? Problem number 2 is understood? Okay. So shall we go for next problem now? Let's go for problem number 3 now. So for that, I will save it. Let's go for 3. So I hope all of you able to see the number 3. Okay. Now here he is asking us to find out V naught. In the previous problem, here he was asking us to find out V naught, and here he is asking I naught. Here he is asking to find out V naught. So this is third solution. We have to find out V naught. Okay, using voltage division law. Let us see how we will solve it. Okay. So where is V naught? Here is the V naught. This is what we have to find out. Okay, this we have to find out, and this given as plus symbol, and this is minus, and this 1 ohm 12 volts, this is plus, and this is minus, 2 ohms 4 ohms 3 ohms, all this. Okay, so now let us do analysis on this circuit. They are in series, so I can replace them with 12 ohms. They are in series. Okay, so I just write the circuit as 12 ohms, and then this is 4 ohms, and then this is 2 ohms. After this 2 ohms you have minus and plus 12. This is 1 ohm. This is the circuit we get, and here we have V naught. We have to find out what is V naught. V naught we need to find out. Okay, now you see here again that this 12 and 4, they are parallel. So if 12 is parallel with 4 ohms, then 12 into 4 by 12 plus 4 is 16. 4 4 is 16, 4 1 is 4 3 is 12. So you get 3 ohms. Okay, so I just write here. You have got 3 ohms and 2 ohms is minus plus 12 volt, 1 ohm plus minus this V naught. Okay, so again from this circuit it is clear that they are in series, so I can replace this with 5 ohm. Okay, so here we have 12 volts minus plus, this is 5 ohms, this is 1 ohm, and here this we have to find out. But you see again, this is open circuit, right? We have nothing, there is no loop here, so current doesn't flows here. Okay, so now these are again in series. So I get 6. Okay. So 12 volt is connected to 6 ohms. Okay. Now we need to only find out V naught. Okay. So for finding V naught, we need to find out the formula. We have V and R according to the Ohm's law. According to the Ohm's law, V is equal to IR. So we have V and we have R. So we can find out I. Okay, we can find out I. So let's call. Any doubt? Yeah, yeah, they are in series because an open circuit. That's what I have written. This is series. Okay, good question. So now V is equal to uh, IR. According to the Ohm's law, we have V is equal to IR. So let I is nothing but IS. Okay. So V is equal to IR. So let us find out what is I is equal to V by R. So what is V here? We have 12 volts. Okay, by R is 6, so we get 2 volts. We get sorry, 2 amperes. Is equal to 2 ampere. Therefore, I get Is is equal to 2 ampere. But this is not I naught. This is not V naught. We have to, why we got this Is, you see, uh, from figure, you see from this figure, okay? From this figure, you see V naught, we have to find out V naught across this R, okay? We have to find out V naught across this R. So the current which is flowing here, okay, this Is is 2 amperes. So because they are in series, same current will flow, okay? So the current which flowing here also is Is, correct? The current which is flowing here is Is. So the current is Is. So V naught is equal to, V is equal to IR. I is your Is and R is 1 ohm resistance here. Okay. So Is is 2 into R is 1 ohm, 2 into 1. So this is 2 volts. So therefore we get V naught is equal to 2 volts. So understood all of you? Any questions? Okay, that's great. So now let's go for problem 4. Okay, so problem number 4. I think you can solve it very easily. So I give this as an homework. 4. You see, they are in series. They are also in series. Okay. Then after you get it, this all will become parallel. Okay, that parallel will become again with series with it. Okay, again it will become series with it. This series will become again in parallel with this. Okay, so I think like this you can solve and find the I naught, right? So can you take this as an homework so that I will solve problem number 7, or you want me to solve this? Please tell me, you want me to solve this or you can solve on your own? Any answers? Can you solve your own or you want me to solve this question? Okay, that's great. We can solve it. So good. Yeah, you solve it. I will go for the same but little difficult problem, which is problem number 7. Okay. So let us solve problem number 7 now. Yeah, this is problem 7. Okay. So in this, he is asking us to find out V naught using current division law and Ohm's law. Okay. So let us see the application. In problem 4 also you have to apply current division law. How you will apply I will show here so that you can also solve problem number 4 very easily. Let us solve it. How we'll solve it? Yes, any feedback? This is V naught, we need to find out. This is positive and this is negative. Okay, so I think we can take this two, they are in series, so it will become 12 ohms. Okay, and I think this is also is in series because it's an open circuit. This is 3 ohms. Okay, so this is the first step, we got it. So in step 1 we have 12 ohms here, and you have 12 ampere of current flowing, 1 ohm, 6 ohm, and here you have 3 ohms, and this is negative, this is positive. This is what V naught we need to find out. Okay, now from this again it is clear that both of them are in parallel. So if 6 is parallel with 3, then equivalent resistance is how much? 6 into 3 by 6 plus 3 is 9, 2 ohms. Okay, so I get the 2 ohms. Now this 2 ohms, how I will put it, it is coming in series with 1 ohm, like this. 12 ohms, 12 ampere, 1 ohm. I get this 2 ohms. I got 2 ohms because I solve it. Okay, I got 2 ohms. Yeah. Then next, you can observe here they are in series, correct? So this will become 3 ohms. So if it becomes 3 ohm, it's very simple that you have 12 amperes of current going. One is 12 ohms and the other is 3 ohms. Okay. Now this is the final circuit we got. Again, you see he's asking us to find out using Ohm's law and also current division law. Can we apply current division law? Yes. This is the total current IS is coming, and here at this point of time the current is getting divided into two parts. Suppose this is I1 and this is I2. So this is a current divider circuit. So we saw that in current divider circuit, yeah, this is plus minus V naught. So in order to find out V naught, okay, I should know I2. So I2, how can I write using current division law? I2 is equal to total current is 12 multiplied by, okay, opposite current is 12 by sum of them 12 plus 3. So this is 12 into 12 by 15. So how much if you solve? 1 minute. Let me check it out. Here this is okay. So 6 is parallel with 3. We got it as 2 ohms. 12 and see, we did one mistake. We forgot this 3 ohms, correct? We forgot this 3 ohm. So let me solve again. So yeah. So we should be very careful that we should not leave any resistance. Okay. So let us solve. So let us make this series. It becomes 12 and this will become 3 ohms. This will become 12 ohms. Okay. Now you see this is 12 ohm and this is 3 ohms. this 3 will become again parallel with 6. This is parallel. Red one is series. I'm just solving directly because already have solved it. You might have seen it. So I just write here 12 ampere. This is 12 ohms. Okay, and this is 1 ohm. Okay, and this will become 3. 3 is again a parallel with 6. So 6 into 3 by 6 plus 3 is 9. It becomes 2 ohms. This becomes 2 ohms, and you see this 3 ohm. We forgot last time this one. Okay, don't forget this. So now, just by seeing the circuit, all of them are in series, correct? So the equivalent circuit I will draw here. So you have 12 ampere current and 1 plus 2, 3, 3 plus 3 is 6 ohms, and here we get 12 ohms. Okay. Now after getting this, we will now find out. So you see this, we cannot ignore this. V naught, this plus and minus, and here also we have plus minus V naught. We want to find out this V naught actually, which is across 2 ohms. Okay, but because in the process of solving we got this. So now look here, if I use current division law here, yeah, I think we can use here. See, this is total current, is 12, and here you are getting I1 and I2 is divided here. Okay, so we use current division law. By using current division law, I want to find out I2. Okay, what is this I2? This I2 is 12. You see this 12, this is I1 and this is I2. And again this I2 is coming here, again it gets divided here and there. Okay, so that you need to remember. So let us find out I2 first. So I2 is equal to, so total current is 12 into opposite resistance is 12 by 12 plus 6, 18. 6 3s are 18. 12 into 12 by 18. 6 3s are 6 2s are 12. 6 3s are 18. 3 1s are 3 4s are 12. 4 2s are 8. So therefore you get I2 is equal to 8 amperes. But what is this I2? This I2, is which is coming at right branch. Okay, what is I1? This is 12 minus I2 will be, okay. So you see here actually this is, if I take IS, this is IS total current. So actually this is what total current IS. Now this IS is divided into two parts. This is I1 and this is I2. Okay, so from this I2, yeah, from this I2 the current is going, and again current gets divided here. Okay, current gets divided again here at 6 ohms, and again it get divides at this 3 ohms. Okay, so the current is same across this. So I will just take the snapshot of this. Look here, total current. This is total current. Okay, IS. So I write this is I2. So I'm drawing from here I2. Okay, from I2 it is going across 1 ohm, and at this point I2 is getting divided. Okay, so you have some resistance, and after that this 1 ohm of resistance. Then at this point of time, at this node, okay, one is going to 6, another is going to 1. This is going to 6 ohms, and this is going to 1 and 2. Now you see, again I take this, IS is getting divided here again into 2. So I will call it is as I3 and this is as I4, for example. Okay. Now I want to find out I4. So how do you find out I4? I4 is nothing but total current. Again current division law. So I4 total current is I2. I2 is, we know that this is 8 amperes. So 8 total current into, okay. So current is getting divided I3 and I4. So take other resistance, 6 by 6 plus 1 plus 2, because this is our in series, 1 plus 2, okay, 3 actually. So 8 into 6 by 6, 7, 8, 9. Okay, so this will be how much? 3 2s are 6, 3 3s are 9, 16 by 3. So therefore I is equal to 16 by 3, which is how much? 3 5 are 15.33 amperes. Okay, now we got this I4. Now see, the I4 here is same across I1 and 4. So now we can find out V0. V0 is equal to, okay, I4 into R2 ohms. So which is I4 5.33 ampere multiplied by 2 ohms. So therefore we get V0 is equal to 10.66 volts. Understood, all of you? Is it clear? Okay, great. So we have solved the 5 problems today. Problem 1, 2, 3, 4th is homework, 7th I have solved it. If you have any questions, you ask me. Otherwise, inshallah, we'll see next week. And make sure that you check announcement. I'll be putting quiz today, okay? Maybe today or tomorrow, inshallah. So check the announcement, right? For the quiz. Any questions? Okay, thank you all of you for your time. So have a nice day and take care. Thank you. Yeah, thank you.